51 and page.
I don't.
It's 308.
308.
Very good.
Also,
317.
And 51 on 317.
Yes, 51 is very
Okay, anything else? 51 on 308, 51 on 317. Anything else?
11.
11 on 317. Okay, anything else? Okay. 308. Let's start with 308. 308.
It's not.
Yeah, eventually I will get to 308. Okay, 312. I get to 310. Okay, 308. 51. Very good. So we have limit. As x approaches 0, it says from the right, 1 over x minus 1 over e to the x minus 1. Is this the problem?
Yes.
Okay, perfect. So I plug in. I can plug in because of what's happening here. So I have to find the least common denominator. So it's x e to the x minus 1, which means e to the x minus 1, which means x e to the x minus 1 minus x. So let's look at this for a moment and say, yes, it's clear, or no, it's not. Is it clear? Yes? Thank you. Okay, perfect. Now I'm going to plug it in and see what happens. I'm really hoping for what? What am I hoping for? Or? Excellent, well done. So this approaches 1. 1 minus 1 minus 0 is 0. This approaches 0. This approaches 1. 1 minus 1 is 0. 0 over 0. Good enough? Should I continue, or can you take it from here? Okay. So limit as x approaches 0 from the right, e to the x minus 1. I will change this into a product as x e to the x minus x. I will differentiate using the product rule. So e to the x plus x e to the x minus 1. And now I check again. The numerator is 0. The denominator is 0.
I have a question.
Yes, please.
Where does that x go on the top? Because on the second limit.
Are we talking about the numerator or the denominator?
Numerator.
Okay, e to the x prime is e to the x, a negative 1 prime is 0, and the negative x prime is negative 1.
Okay.
And this is just this. Anything else? Other questions for me? Anything else? Are we okay with this? Any questions? Okay, moving on. Okay, limit as x approaches 0 from the right. Since it's 0 over 0, this is 0. This is 1 minus 1 is 0. I still have 0 over 0. The numerator goes to, or when I differentiate, I get e to the x. When I differentiate, I get e to the x plus. When I differentiate as a product, I get e to the x plus x e to the x. And the negative 1 is prime is 0. The numerator goes to 1, and the denominator goes to 2. So it's 1/2. What was the difficulty here? Because I like to understand what wasn't clear. I mean, this is pretty straightforward.
How to start it.
I knew how to find them.
Find the least common
I knew
denominator.
how to find this common denominator, but in my head, when I was doing that, I forgot to cancel out, like when I did x e to the x minus 1 instead of the top, I forgot to cancel out the x on the 1 over x and the e to the x plus minus 1 on the other side. So I was just getting a lot of extra numbers and letters.
So the differentiation was the problem.
The starting differentiation, but it was like, I knew what to do, but I was just doing the math itself wrong.
Okay. Anything else? Other questions on this? Okay. So we're looking at 51 on 317. 317. 317. 51. X e to negative 1 over x. Yes? 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 When x approaches 0, the top approaches 1, this approaches 1, this approaches 1, and this approaches 0, because it's x in front. E to 0 approaches 1. So 1 at the top, 2 at the bottom, and a 0. This is 0, 1, 1. Everything else okay? Okay, so how do we start? We're asked to do everything for this function. What is the starting point?
Domain.
Perfect. Excellent. Domain. So let me just write a little bit here and start my table on the next page, if you don't mind, because I need more room. So always remember, if you do not want to work with this table, I'm fine. But you must organize the information somehow. If you don't organize the information, you will not be able to realize when you have an error. Like, for example, last time, if you remember, I did not copy the power. I was, trying to finish everything in 15 minutes, which is a bad idea to rush. No excuse. I didn't copy the power too. And of course, I realized that everything was messed up. So summarizing the information is absolutely crucial. Yes, Ricky?
Like if we did it in 2 parts.
Yes, you'll get it back.
Okay.
Okay, very good. So let's start with the domain. I will also write solutions for you as well.
Okay.
So x cannot be 0, correct? So then the domain of this function is this. Is this acceptable? Is that clear? Yes, everyone? Okay. So negative infinity is 0. If the function is undefined at 0, its derivatives will be undefined at 0, of course. Okay, so let's see what we can learn from the function, about the function from the function itself. So first of all, I will have to determine this, this, and this, as well as, of course, they're all limits. Of course, also x and y intercepts. So let's find the limits as x approaches infinity from x e to negative 1 over x. Yes, Ricky, you wanted to say something?
So it can't be 0 because of the x in the denominator.
Correct.
Okay.
Yes. Everything else works.
And having a exponent undefined means always undefined.
But I can't plug x. I can't plug 0 in the function. So I can have e to any power, but I can't have e to undefined. Is that clear?
Yeah.
Okay, very good. So let's find the limit to infinity, which is this limit. Ready? So this approaches,
Infinity.
perfect. This approaches,
0.
okay. Now this approaches,
1.
excellent. How much is infinity times 1? Excellent. Remember, once we put all the information in the table, it's going to be very easy to identify our mistakes. Once we are trying to graph, if this first row for the derivative does not work well with the function values, then we always catch our mistakes, sooner rather than later. Okay, very good. Now let's determine the limit at the other end. Limit as x approaches negative infinity from x e to negative 1 over x. Where does this go? Still to 0. Very good. Where does this go? 1. Where does this go? So the answer is? Excellent. Well done. For the x-intercepts, I have to make the function 0. X e to negative 1 over x equals 0. But this is never 0. And this is never 0 because in this problem, I can't have 0. So I'll say none. There are no x-intercepts. Now for the y-intercept, I have to plug in 0. Again, none. It's not possible. I can't plug in 0 in this function. So there are no x and y intercepts. Final steps, the limits left and right of 0. And then I can move on to the first derivative. So we want limit x e to negative 1 over x as x approaches 0 from the right. Where does this go? Excellent. Now we have to be careful with this one. Remember the graph of 1 over x. This is not 1 over x. This is negative 1 over x. But let's refresh our memory on 1 over x. By now, I'm sure everyone remembers the graph of 1 over x. It's this graph. Now, we want to graph negative 1 over x because this is what we have here. So this piece moves below. This piece moves above. So this is the graph in red, is the graph of negative 1 over x. So 0 from the right for negative 1 over x. Where does this go when 0 is from the right? Or we approach 0 with x values from the right of 0. We're talking about the red graph. Very good. So this approaches negative infinity.
Can you explain that?
Yeah, it's the graph. If x approaches 0 from the right, the function values approach negative infinity. That's why we graphed it, because it's easier to explain. Very good. Where does this go? E to negative infinity. I shouldn't be writing this because we really don't write this, but let me do it. Where does this go? Of course. So this approaches 0. How much is 0 times 0? So this was from the right of 0. If I need to go through this one more time, I will, with pleasure. Is this clear? All the steps. Yes, Vanessa?
Does that negative infinity really look like,
Yes.
oh, it never, yeah.
That's why. That's why I needed to graph. That's why we needed to do it piece by piece, because it's not clear. It's not an easy situation. You really have to look at it piece by piece. Do you understand this, everyone? I couldn't even see it myself, where it would go. So that's why I had to take it from the inside to the outside for the function composition. Okay, so now we look at the limit as x approaches 0 from the left, from x e to negative 1 over x. Okay. Where does this go? Of course, there is no question there. So now, careful with this. Where does this go? Right. This one goes to infinity. How much is e to infinity? Where does this whole thing go then? E to infinity, no. E to infinity goes to? It's so big that I cannot even mention it. It's in super infinities. It's e to infinity. It's almost 3 to infinity. This is so big I cannot even say anything else, right? Oops. 0 times infinity is what? Very good. One of the 7 indeterminate cases. Thank you, Chris. So I have to work on it. I can't draw any conclusions here. So let's work on it. So limit as x approaches 0 from the left. And this is the obvious thing to do. What am I after? I have 0 times infinity. And I wish I could change it into either Or, excellent. So is this okay? Is this the same? Yes, because when I flip 1 over x, I get x in front. Would you agree with that? But now, where does this go and where does this go? And I'm hoping for exactly what you just said. I'm hoping that I change the indeterminate case 0 times infinity into, that's my hope, either 0 over 0 or infinity over infinity. Now the top goes to the same place. I didn't change the top in any way, shape, or form. But now I want to know where this is going and look at the graph. So as, yes, awesome. As the sign is not important, right? So, but indeed, 0 from the left of 1 over x is the green graph, is negative infinity. The sign is not important. It can be infinity over infinity or infinity over negative infinity. It doesn't matter. But I like this. Why do I like it? Because I will differentiate the top and I will get, yes, I'm sorry, Braden. Go
I
ahead.
was confused on how you got how you changed x e to the negative 1x to the e to the negative 1x over 1x.
Yes. So when I divide by a fraction, I have to flip the fraction like that to multiply. When I divide by a fraction, I multiply by the multiplicative inverse of the fraction. So if I divide 10 by a over b, I have to write 10b over a. So if this is 1 over x, then I have to write x over 1. So when we divide by a fraction, we literally multiply the numerator by the multiplicative inverse. So if I have 10 divided by 1 over x, this is 10x, because I have to flip. Okay, a divided by b, everything over c over d. I copy the numerator and I flip the denominator. So when we divide by a fraction, we really multiply the top by the multiplicative inverse of the denominator.
I'm still not
So because she had the, because it was like x times the e to the 1 over x, so if you were like, technically it's x over 1 times e to the negative 1x, so to put it in the denominator, you would flip it, so instead of it being x over 1, it would be 1 over x.
Is that better? Excellent. Clear? Okay, great job. Thank you, Ashley. So now what is the numerator prime?
1 over x squared.
The numerator prime. Yes, e to negative 1 over x times. Excellent. What is the denominator prime?
Negative 1 over x squared.
Excellent. I like it. 1 over x squared with 1 over x squared, the denominator go away. So where does this go? So remember we had this before right here. E to negative 1 over x, when x approaches 0 from the left, bless you, negative 1 over x, e to negative 1 over x goes to infinity, but there is a minus sign in the denominator. So what will I have to write here? Excellent. So negative infinity. After all this work, we only determined 1, 2, 3, 4 things and the domain. A lot of work. Okay, now we're ready for the first derivative. Any questions? Any questions? Okay, so let's start now. I copy the function one more time, x e to negative 1 over x. So let's find the first derivative. Can anyone help with the first derivative? Very good, very good. We don't need the logarithmic differentiation because we can differentiate. It's a product. Good, ready?
E to the negative 1x
Very good.
plus x times e to the negative 1x plus times 1 over x squared.
Yes, because it should have been, when I differentiate this, I get negative 1 over x squared, but there is a minus in front. That's why we change it into. Very good, awesome, great job. Of course, I will simplify 1x. I will factor out e to negative 1 over x, and I have 1 plus 1 over x. Let's stop for a moment and see if this is clear. So I simplified an x with an x squared from the denominator. I still have 1 over x. And of course, I pulled out e to negative 1 over x, and I got 1 plus 1 over x. Is this okay, everyone? Are you with me? So obviously, this changes into x plus 1 over x, and you can put this in the denominator as 1 over x. Okay, I have the first derivative. What do I do with it? I'm happy. I got the first derivative. Now what?
So equal to 0.
Correct. What am I trying to find?
Critical number.
Excellent. So f prime of x is 0. There is only one answer. And that answer is?
-1.
Excellent. I go back quickly back to my table. I put -1 and 0. Can this function be undefined? Remember, critical numbers may come from f prime being undefined. This is never 0, and this is 0, where the function is undefined. So no critical numbers come from f prime being undefined. This is the only critical number. Okay, now I need to study the sign. Which of these p's, or which pieces or piece from here I don't have to worry about? Which one I will waste my time if I plug in numbers? Which part of the bottom? Of course. This is always a positive number. I don't care about it. So I'm going to make sure that this and this, whatever. So to the left of -1, let's plug in -10. -10, so don't worry about this one. -10 plus 1 over -10. I only need the sign.
This one's positive.
Positive. -10 plus 1 over -10.
I got that.
That's okay. Now we want to plug in -0.5. -0.5 plus 1 and -0.5 in the denominator.
Negative.
-0.5 times plus 1 over -0.5. Top is positive, bottom is negative, negative. Agreed? -0.5 plus 1 is positive, -0.5 is negative. Better? Perfect. Now on the other side, let's plug in 10. 10 plus 1 over 10. That's it. Now the moment of truth. If these two don't work well together, I'll say oops and try to look for my mistake. Okay, I have to plug in -1 in the function and find the y value before we proceed. So -1, I have to find f of -1. F of -1. So I have -1 e to the first power. So this is negative e. And this is -2.7. 8. Only in the original function. This is the original function, right? It's the point, the y value for the x -1. I have to plug it in the original function. I don't care in the second derivative, and I know the first derivative is 0. So in order to find the y value, I have to plug in -1 in the original function. Okay, ready? From -infinity to -2.78, what does the function do? Is that supported by the sign of the first derivative? Very good. From -2.78 to -infinity, what does this function do? Is that supported by the sign of the first derivative? Excellent. From 0 to infinity, what does this function do? Is that supported by the sign of the first derivative? It appears that everything is smooth and clear. Now let's look at the second derivative. Do I want to look at the second derivative? No. But I have no choice. So I'm going to use this format. The simplest to differentiate. So I'm going to copy the first derivative so for everyone to see. So the first derivative is e to -1 over x plus 1 over x e to -1 over x. And can anyone tell me? I'm on page 4. Okay. So the second derivative. This we already differentiated 3 times, so it's e to negative 1 over x times 1 over x squared, plus, I have to be careful with this because this is a product rule, or you can use the quotient rule. I prefer the product rule. That's why I replaced it by 1 over x and times this. So this prime is negative 1 over x squared times e to negative 1 over x, plus 1 over x e to negative 1 over x times 1 over x squared, as we looked at before. Okay, my wish kind of came true because, so I have 1 over x to the third e to 1 over x. Not too bad. Because 1 over x squared with negative 1 over x squared, and they have both a e to negative 1 over x, they go away. They're opposite terms. So all I have left is that. And just for the purpose of studying the sign, I'm going to write this. And I'm going to ask you again. Yes, please, Vanessa.
I'm confused how you got from the prime to the 1 over x.
Let's do this one more time. Okay. When I differentiate e to u, I have e to u. E to u prime is e to u times the inner function prime, which is this. Plus, this is a product. I differentiate 1 over x to get negative 1 over x squared. We remember it from a long time ago, times the second function plus the first function times the second function prime, which is that. Again, e to negative 1 over x times 1 over x.
Okay, how'd you get that though? The one on the bottom, 1 over
X times x squared is x cubed. And I brought e to negative 1 over x back to the denominator.
Okay.
And now I split it just for the purpose of the sign. Which piece from here you're going to plug in, and which piece or pieces you're not going to plug in? And also x squared. That's why I separate like that. X squared is always positive. E to 1 over x is always positive. Don't worry with positives. Of course, this is never 0, no matter what. So the sign of the second derivative will be given just by this little piece. So I'm going to go back. If x is less than 0, what is the sign of the second derivative? Very good. If x is positive, what is the sign of the second derivative? I wouldn't test symmetry, although it has a vertical asymptote. That's x equals 0. VA, of course. As long as at least one side is infinity, this must be a vertical asymptote. Regardless of one of them being a number, it doesn't matter. Okay? If one or the other is positive infinity or negative infinity, that must be a vertical asymptote. Ready? I don't care for any work. All pages mean nothing to me. This is all I need. Ready? I only have 2 points. Oh, I forgot to ask you. Negative 1 comma negative 2.78. What type of point is it? Thank you. So negative 1, 1, 2, 3, somewhere here. And 0, 0. Of course, you understand 0, 0 cannot be a point. It has to be an open point. Function is undefined at 0. Okay, so coming from negative infinity, increasing,
What point is that?
of course. Thank you. I got it. You don't trust me anymore. You're shaking my trust in myself. Okay, 1, 2, 3. Okay, I think I'm okay now. Thank you. My apologies. Okay, I would have, because I was thinking right this moment, how can it be up here since we don't have an X-intercept? So it would have hit me sooner than later. Very good. From negative infinity, it goes up to this point, negative 1 comma negative 2.78, opening downward, and then going to negative infinity on the left-hand side of the vertical asymptote. Very clear. On the other side, it opens up, increasing from 0 to infinity. Thank you for your patience with this problem. So f of x equals x e to negative 1 over x. Okay, any questions? Any questions? Good. It was a good problem, good exercise. Okay, so moving on. There was another problem that we wanted to look at. Let me go back. So 11 on 317. 11. So y equals x minus x squared divided by 2 minus 3x plus x squared. I think that this can be done. I don't think you can still work on it for Thursday, but I don't see the problem with this. Yeah, I completely agree with the previous problem we had to go through it together. Absolutely. But I don't see the problem with this. What do you think is the problem with this? Factoring what? Factoring? So first you have negative x and x minus 1, and then you have x minus 2 and x minus 1. And what is the problem from here?
We have done this.
So x cannot be 1, x cannot be 2. We did this problem in class?
No, that was homework.
Okay, so what would be the problem? Then this will be a hole in the graph. And you have negative x over x minus 2, which will take you 3 minutes to graph and go through all the steps.
Oh, then this
Is that okay? Yes? Yes, Vanessa?
It's the same
It's
one. It's like the same.
one.
We have to graph everything, right?
Yes.
Okay.
Yes, you have to find all the limits. You have to explain, you find the limits for the whole left and right. If it has vertical asymptotes, horizontal asymptotes, everything. Yes, the first derivative, the second derivative, everything. But this is what the next test is all about. So I'm hoping that at least you're not going to just do one problem. Please don't do just one problem, please. Okay, do we go back to the previous problem that from class that we didn't finish? Yes or no?
Yes.
Because I didn't get the chance to. I collected the information, but I didn't get the chance to graph it with you. So if you say we can graph this on our own, then we'll go and review. What would you like me to do? I'll do whatever you want me to do.
Let's just finish it.
Let's finish it. Very good. Well done. So, but is it okay with this? Will you be able to finish this one? Yes? Everyone? Yes? Okay, perfect. So then we have f of x, which is negative x over x squared minus 1, or negative x over x minus 1, x plus 1. I think I have enough room for my table here, so I'm going to start here.
Are we redoing the problem?
We are starting from scratch the problem that we did not finish last time when my computer collapsed, the power went out. Okay, last time you already gave me negative 1 and 1 as the domain. These two factors stay, so x equals negative 1 is a VA and x equals 1 is a VA. If you remember when we plug in 0, we do get 0. And now let's again find all these limits. Because you understand what we're trying to do. I'm sure since we've looked at these problems before, it's not the first one. What I'm trying to do, number one, is exhaust all the information I can find about the function from the function itself. Basically limits, x and y intercepts. There is nothing else. After I'm done with this row, then I continue with the first derivative. Then I stop, and I make sure that these two rows work well together. That's the moment I see, oops, something is wrong, right? And only then at the very end, I look at the second derivative. Is that clear? Are the steps clear? First the function, then the derivative, and then the second derivative. Okay. So let's find these limits again. So limit Sx approaches negative infinity from negative x over x squared minus 1. Now, this is good for finding the domain, but it's not good for differentiating, for example, or for limits. Not really. Although, if the limit is infinity, this may work better. So it depends. One or the other. Okay, what is the limit as x approaches negative infinity of this? Okay, perfect. So it is indeed infinity over infinity. So then I can use L'Hopital's rule. And the top is -1, and the bottom is 2x. Now, when x approaches negative infinity, this will approach. You all agree with that? Which immediately I know that this must be the case. Back to the chart. Let's find the other one, but it's not going to make any difference. So when x approaches infinity, the answer will still be 0. Do you want me to write the one with infinity? Or do we agree that we have not used the symbol? Any number over any type of infinity is 0. Is that clear? Perfect. So now we need these limits, left and right, because I know that these are vertical asymptotes, but I don't know the limits. So let's find limit. As x approaches -1 from the left. And now, maybe in a way, I prefer this form of the function. So limit as x approaches -1 from the right, -x, x minus 1, x plus 1. I'm writing all 4. So this is 1 from the left. Don't let me forget to discuss the next test when and where, okay? Before we finish today, we adjourn today. Okay. I know the answer. I have no doubts. None whatsoever. Because I already established they must be vertical asymptotes. These functions, this function is rational. So the answer must be infinity. What I don't know is the sign. Okay. So -1 from the left. -1.1. Negative, negative, negative. -1.1 at the top, -1.1 minus 1, -1.1 plus 1. I see 4 negatives, sign. Excellent. -1 from the right is -0.9. Negative, negative, but positive. And I see 3 negative signs now. With 1 from the left, 0.9, positive, negative, and positive. Excellent. And 1 from the right, positive, positive, positive. And I only see 1 negative. So I'm going to write infinity, then negative infinity, then positive infinity, and then negative infinity. Bless you. So now I'm completely done. I'm completely done with the function. There is nothing I can find about the function from the function itself. Now I'm going to differentiate, obviously, this piece, not this. This form, not this. So f prime. Leave x out, -1 outside. The top prime is 1. X squared minus 1 minus x times the denominator prime, which is 2x over x squared minus 1 squared. So x squared minus 2x squared is negative x squared minus 1. Negative x squared minus 1 over x squared minus 1 squared, but this changes into x squared plus 1 over x squared minus 1 squared, which is awesome. Why? because it's always positive. And it's never 0. No critical numbers. If the function doesn't have critical numbers, you will definitely not have
Max min.
max min. Max min. Good. So I have to go back and put positive everywhere. And now the moment of truth. Ready for the moment of truth? In this case, in this situation, I should find my mistakes. I'll say, oh, it makes no sense. And if I manage to teach you in this class when to say, oops, it makes no sense, I'm very happy. Because it means that you learned a lot. Okay, from 0 to infinity, what does this function do? Is that supported by the sign of the first derivative? From negative infinity to 0, is that supported by the sign? Yes? From 0 to infinity. From negative infinity to 0. Right. Okay, now let's look at the second derivative. And this time we're going to look at symmetry for this function. Okay, if you ask me, do I really want to differentiate this? My answer would be no. But here's the second derivative. Top function prime.
2x.
Excellent. X squared minus 1 squared minus x squared plus 1 times the denominator prime. This denominator prime. Very good. Times x squared minus 1 times. Excellent job. Of course, immediately I am going to pull out what from both?
X squared minus 1.
Very good. So one of these and definitely 2x. 2x is out and x squared minus 1 is out. X squared minus 1 to the 4th power. Only now I can do this. Not before. Once it became a factor, I can simplify. Okay, very good. So then let's see what is left. What is left from the first term? 2x is out. One of these two is out. So I still have an x squared minus 1 inside. And then I reached minus. Is everyone with me so far? Yes? Stop me if you have questions, please. Okay. This is out. And this is out. But I have to distribute 2 to x squared and 2 to 1 with minus in front. Negative 2x squared minus 2. Is this okay so far? Yes, Vanessa?
Why wouldn't you factor out the second x squared minus 1?
Because this one is x squared plus 1.
Oh, okay.
I wish I could, but you're right. But it's x squared plus 1. Okay. So then in the numerator, oops, that's not good. In the numerator, I have 2x, and then I have negative x squared, and then I have negative 3. Negative x squared and negative 3. X squared minus 1 to the 3rd.
Good question.
Yes, please.
So is it supposed to be 2x squared minus 2 or is it 4x?
So let's check. I have 2x and x squared minus 1 out. 2x is out. One of those is out. One of them is in, and I reach minus. 2x is outside. X squared minus 1 is outside. So from this term, all I have is 2 and x squared plus 1. That's okay. It's better to go back and check. Negative 2x squared and minus 2. You may see, that's why I always encourage my students to speak up. You may see something I don't. Remember last time I didn't copy power and the whole thing got messed up. So I would rather go back, even if there is no mistake. Please, I will either go back. I will always rather go back and check than be sorry later. Okay, so this is negative x squared minus 3. These two are both negative. I will put negative outside. 2x, x squared plus 3. And I will split the denominator. And you will tell me why I split the denominator.
X squared plus, x plus 1, x minus.
X squared plus 3 is always positive. X squared minus 1 squared is always positive, so I'm not going to worry about this. This can never be 0. So the second derivative equals 0 means only x equals 0. Only this piece can be 0. No other piece can be 0. So I go back to my table, like 15 pages ago, and I put 0 for the second derivative at 0. But now I need the sign. And of course, I'm not going to worry about this piece. Everything that is shaded, don't worry about it. They're all positive. But I have to plug in x. I have to worry about this, and I have to worry about this when I find the sign. Ready? So let's pick a number here. 1 here, 1 here, and 1 here. For the sign, yes, for -3, perfect. For -3, this is negative. But this is 9 minus 1, so this will be positive. And I see 2 negatives. Now to the left of 0, but not past -1, so -0.5. With -0.5, this is 0. But with -0.5, this is 0.25 minus 1. So this will be negative. Negative, negative, negative. This will be negative. On the other side with 0.5, this will be positive, but this will be negative, and the negative. So it's positive. And finally, for 10, it will be negative. So what type of point is 0, 0? An inflection point. Let's discuss this. Careful. If only one answer I got, only one student said this, then we have to go back to it and talk about it. So when we find that the second derivative is 0, and it changes sign, at that point there is an inflection point. Why? On that side, it's opening downward. On this side, it's opening upward. See the signs? Down, up. Also, if it's undefined, where the function is defined, that is also an inflection point. But the function must be defined there. So it's not the case here. For example, you could say, how come it's 1 comma blah is not an inflection point? The function, the second derivative changes sign. True. But at 1, the function is not undefined, so it cannot be an inflection point. But if the function were defined here, and we would have gotten it undefined only for the second derivative, defined here for the second derivative, then this point would have been an inflection point. Even if the second derivative is undefined, only because it changes sign, and the point exists. Good. So we are ready. I don't care for any work except my table. Nothing else matters. So let's graph. When we graph a function with asymptotes, what do we have to graph first?
Asymptotes.
Correct. Thank you very much, Braden. So there is no point in reinforcing, but I will reinforce the y equals 0 and x equals -1 and x equals 1. Please write -1, x equals 1, and I forgot, and I mentioned, we want to talk about symmetry. Very important concept. So f of -x equals f of x. The function is even. F of -x equals the opposite of f of x. The function is odd. And that's exactly what happens here. When we determine f of -x, we have this. So the function is x over x squared minus 1. So I replace x by -x. -x at the top, -x squared minus 1. So see what happens? The negative with the negative will go away. And the -x squared is x squared minus 1. And this is exactly the opposite of the function, which is typical for an odd function. I showed that f of -x equals f of x. So that's an odd function, which means whatever I graph, it must be symmetrical with respect to the, Reagan?
Oh, I just had a question.
Yes.
Is f of negative x the same as negative f of x always?
No. But if it happens to be,
That's odd.
then it's odd. Because remember, I cannot move this outside. This is just f of 2. F of 2 or f of negative 2 will not be simply moving negative 2 outside. I have to plug in negative 2 all the way. Better? Okay. Any questions? So keep that in mind. Symmetric with respect to the origin. Symmetric with respect to the origin. Okay, back to my graph. I have 0, 0. On the left-hand side, from 0 up to infinity. That's good. Opening up, increasing from 0 to infinity. On the left-hand side of the first vertical asymptote, from negative infinity, opening down to the inflection point, and then continuing opening up to infinity. Of course, by symmetry, I should just copy. It's very clear. This has to be here as well. I don't have to look the rest of the table. So this function was negative x over x squared minus 1.